thing that this section talks about is the division algorithm, which is the first thing that the next section mentions as well. It basically says if you have two polynomials, you can rewrite the one with the highest power as the second times q plus r. Q meaning quotient, r meaning remainder. So it's basically saying we can divide those things. We can do long division, but if you are dividing by something linear, then you can do what's called synthetic division, and that's like a shortcut. So I have walked through a sample problem already on this notes handout. If you had 3x cubed minus 2x squared minus 150 divided by x minus 4. The very first thing you do is find k. K is what makes this 0. So what makes x minus 4 0? 4. So that is the number that goes out in the box for your synthetic. Then you put your coefficients. You know, I notice I have a 3 at -2. Why did I put a 0? There's no x. Remember, in synthetic, you have to have that 0 as a placeholder. And you do need your constant. Okay, then we always skipped a line. And the first number comes all the way down. So I drop the 3 all the way down to the bottom. And then it's just a series of multiplication and addition. You do 3 times the number in the box, which is 12, add -2 plus 12 and gives us 10. And then we repeat. 10 times 4 is 40, add, and you get 40. 40 times 4 is 160, add those things, and you get 10. So then, you can rewrite this in terms of your answer. That final number is always your remainder. You have your constant, your x, and your x squared. So our quotient was 3x squared plus 10x plus 40. And then you always put your remainder over what you were originally dividing by. Okay, so I would like for you guys to try this example here. Go ahead and set up your synthetic division for that one. So what number goes in the box here? -3. Then your coefficients are 2, 5, -2, 2, -2, and 3. Okay, so 2 comes down, multiply and you get -6, add and you get -1. Multiply, we get 3, add, we get 1. Multiply is -3, add and we get -1. Multiply is 3, add and we get 1, and finally -3 plus 3 is 0. So my remainder is 0. This is my constant, x squared, x cubed, and x to the 4th. So my answer is 2x to the 4th minus x cubed plus x squared minus x plus 1. And since my remainder was 0, I could leave that off. Now the directions on this one actually ask for more than just the division. It says show it's a factor. Factors are things that divide evenly. So it says right underneath here, if something is a factor, the remainder is 0. That is really the piece of this section that we are going to continue using when I start section 3 in a little bit. So factors divide evenly. They have a remainder of 0. Just a few reminders with synthetic division. It only works if you have linear factors with leading coefficient of 1. So you have to be dividing by something linear. We can't do synthetic division if you're dividing by an x squared or anything like that. You have to include those 0 placeholders. Those are absolutely necessary. And don't forget, at the very end, your final number is your remainder. All right. The next piece here that I want to mention is what's called the remainder theorem. Okay, sometimes we don't really care about what the quotient is when we divide it. We only care about the remainder. Okay, especially if we're thinking about factors, we know if something's a factor, its remainder should be 0. So we could find our remainder by doing this full synthetic division, and there is actually an incorrect. There's a mistake on your handout. This should be a remainder of -14 right there. But anyway, in this case, if you did this synthetic, you would get a remainder of -14. And we could could do that. The remainder theorem says if all you care about is the remainder, you don't actually have to do the full synthetic. You just have to plug your k value into this problem. So for instance, if you plug 2 in for your x in that problem, so if you do 2 times 2 to the third minus 3 times 2 squared minus 18. Did we get negative 14 for our answer? Yes. So, part B. I want the remainder. There are 2 ways of getting it. I've told you that your k here is negative 3. That might also mean you are dividing by x plus 3. So just keep in mind you might see either of those 2 things. If I want my remainder, tell me one way to get it. Plug in negative 3. What's the second way of getting it? Synthetic. Let's plug in the negative 3 on this one. So if I just did f of negative 3. What'd you guys get for your remainder? 0. The question here was to decide if k was a 0. Okay? K is a 0 is the same thing as saying is x plus 3 a factor. It means does it divide evenly. So is this one a 0? Yes. Okay, C. What's different on this one? K has an imaginary number. So can you just grab your calculator and start plugging that in? No. So plugging it in is not going to be efficient here. How else can I decide? We can do synthetic. So since I gave you the k value, that's what goes out in the box. So that's 1 plus 3i. Then you put your coefficients. Leave yourself plenty of room in between those. Okay, first number comes all the way down. One times 1 plus 3i is just 1 plus 3i. When you add those, what happens? The 1's cancel and you get 3i.
Any senior that needs to place your order with Johnson's, you need to report to the library at this time. Seniors that need to place their order with Johnson's need to report to the library at this time.
Now I have to multiply the 3i times this. If you need to, you can write it out to the side. 3i times 1 is 3i. 3i times 3i is 9i squared, which is negative 9. So I get negative 9 plus 3i. Add like terms, and that gives me negative 3 plus 3i. What do we have to do now? Multiply. I have to take 1 plus 3i times negative 3 plus 3i. So we have to FOIL those, but we've done that before. It's not anything new. So that would give me negative 3 plus 3i minus 9i would be minus 6i plus 9i squared, which is negative 9. So that gives me a negative 6 minus 6i. Is everybody with me still? We need to add. You can only add like terms, so 14 and negative 6 is 8. So we have 8 minus 6i. Yep, that is a -3, isn't it? I think I carried over a +3. Okay, so that's -12 minus 6i. So -12 plus 14 is 2 minus 6i. So now what do we have to do? Multiply. We have to take our 1 plus 3i times the 2 minus 6i. So if we FOIL, we get 2 minus 6i plus 6i, so those drop, minus 18i squared. So that's 2 plus 18, which is 20. Add those and we get 0. My question was, is this a 0? Yes, it is. So you can do that division even if you have imaginary numbers along the way. You might just have to go out to the side and have a little scratch. Are there questions on that? So that is the first half. The assignment for this section is on the bottom of this page. We're not working on that yet. Keep in mind, it's 1 through 57, every other odd. So you're not actually doing that many problems there. So you'll do like 1, 5, 9, and so forth. They are odd problems. So I kind of did that on purpose. Since I'm going to be gone, you can check yourself in the back of the book. But that means if you have an answer and no work, you get no credit. Okay, so you have to still work everything out. I just gave you the odds so you can check yourself and make sure you're doing it. Okay. Any questions about that? So that's part 1. We are not doing this entire section today. I am just starting it, and then we will finish on Wednesday. But we do need to get through part of it. The first few things on here are very similar to what was said already on the last handout. This was that box at the very top of the other handout. Basically says if you have 2 polynomials, you can always divide them and get a quotient and a remainder when you do that. Terminology, f of x is what's called the dividend, g of x is what's called your divisor, q is your quotient, r is your remainder. You've heard those terms before, hopefully. The factor theorem, like we already mentioned in the last one, x minus k is a factor if, when you plug in k, you get 0 out. Or if you do the long division and get a remainder of 0, then it is considered a factor. So, first thing, I want to know for this function if x minus 1 would be a factor. So there are 2 ways of doing it. You can do synthetic, but the easiest way is just what? Plugging it in. You have to plug in your k value though. What is my k here? 1. Think about if you were going to do the synthetic, what would go out in the box? It would be 1. It's what makes this 0. So you need to find f of 1. So if you plug a 1 in there, you get 2. And what do we get for our remainder? 0. So is this a factor? Yes. Okay, so if I want to decide if x plus 2 is a factor, what am I plugging into my equation? -2. What do you get this time? What did you get? -27. So is that one a factor? you guys do the next one. Decide if x minus 2 is a factor of this polynomial. And what did you guys get? So, is that one a factor? No, also not a factor. If I asked you why, it's because the remainder is 8. If you were to divide them, you have 8 left over to divide evenly. Alright, that part okay? The next thing we are going to do is factor polynomials. Now, you guys are really good at factoring like quadratics when you can do box method. The only way we've been able to factor things with a cube is if we could do like a raised common factor or grouping. We are working our way up to how to factor things that don't factor with any of the rules we have so far. So, our first step, I am going to give you a starting point. So here is my function, and I'm kind of giving you a hint. I'm telling you that 5 is a 0 of this function. That means that x minus 5 divides it evenly. So what we are going to do is start with that 0 and do synthetic division with that. So I'm going to put my 5 here, and then my coefficients. And I already know, what should I get for my remainder at the end of this? 0. If I don't, I have made a mistake because I already told you it will be 0. So remember, the 6 comes all the way down. Multiply, 6 times 5 is 30. And then we get negative 7. Negative 7 times 5 is negative 35. And we get negative 3. Negative 3 times 5 is negative 15. And we get 0. What I want you to do is write this piece. You know, that's our remainder. This is our constant. This would be x and x squared. So right now we have 6x squared minus 7x minus 3. Can you factor that? That's a quadratic. So I will ask you to factor this all the way. So now we're going to have to do box method. So my 6 goes here. 6x squared and my negative 3 goes down here. Those multiply to negative 18. And I need my numbers to add to negative 7. So what would that be? Negative 9x, positive 2x. So factor, we get 3x, 1, 2x minus 3. So my directions here were to factor this. It factors into 3x plus 1, 2x minus 3. Is that all? Now, this was originally an x cubed. If I multiply this, I only have an x squared. What else do I need on this? Remember I told you 5 was a 0? So if 5 is a 0, what goes in here? X minus 5. The general rule of thumb, if it's an x cubed, you're probably going to have 3 parentheses. The next to the 4th, you're probably going to have 4. There are exceptions if we get into like a quadratic that doesn't break down any further, but as a general rule, that tells you the highest power tells you how many parentheses we should Any questions right there? Let's look at the next one. So we did a synthetic already today with an I. We're going to try another one now. So if I give you the K value or the 0, that is what goes out in the box. My coefficients here were 2, 3 minus 2i, negative 8 minus 5i, and 3 plus 3i. So first step to synthetic, the 2 comes all the way down. Now you have to take 2 times the 1 plus I. So if you distribute, you get 2 plus 2i. Everybody with me so far? So if we add those, what happens? 2i's cancel and we just get 5. So now you have to take your 5 times the 1 plus I, and that gives you 5 plus 5. Add and I get negative 3, so we have to do negative 3 times the 1 plus I. Get negative 3 minus 3i, which does give me a 0. And I knew it was going to be a 0 because I already told you at the beginning that this divided. What's the next step? Box method. Right now this is a, remember that's your remainder, your constant, x and x squared. So we have 2x squared plus 5x minus 3. Set up your box method. Multiply negative 6. Add to positive 5 would be positive 6. So we get x plus 3, 2x minus 1. Okay, now be very careful. You are trying to write the factored form. This was originally an x cubed, so I should have 3 factors. Right now I only have 2. If 1 plus I was a 0, your factor is always x minus that. So if I did x minus the 1 plus I, that gives me x minus 1 minus I. So this is the final answer. That is the factored form right there. If I give you the 0, you have to do x minus that for the factor. Okay. Questions right there? I want you to start the next one on your own. The directions are slightly different. I asked for all the remaining zeros. Go ahead and do the factored form for me first. Okay, so start this, factor it down, and then we'll talk about the next step. So this 3 is a 0, so you start with your synthetic. So that goes to x squared plus 2x plus 2. Can you do box method for that? No. I asked you to find the remaining zeros. I told you the first one is x cubed, so there should be 3 of them. Keep in mind, zeros are just a number. 1, 2, 3. Factors are where you have the x minus 1, x minus 2, x minus 3. So the previous problems I asked you to factor. That's when we have the x with it. I'm asking for the zeros. I'm asking you to solve it. How do you figure out what makes this equal 0 if it doesn't factor nicely? Could use a graph calculator, we also have quadratic formula, don't we? So, because they could be imaginary, we need to do the quadratic formula here to finish it. So x equals the opposite of b, so -2, plus or minus the square root of b squared minus 4ac all over 2a. Under my radical, I have 4 minus 8, which is -4. What's the square root of -4? 2i. So I get -1 plus or minus I.
How did you find that out?
You can't, because they're imaginary. It will only give you the real ones. So this one we didn't have an option. I didn't ask for all the zeros. You know, altogether there would be 3 of them. I only said give me the remaining ones. So this would be it. -1 plus I and -1 minus I. Those are my remaining zeros. One more. So if 3i is a 0, we have to begin our problem by dividing. Remember on that synthetic, if we did have any missing powers of x, we need to put a 0 in for them. So then my 1 comes down. 1 times 3i is 3i. Add those, and we get 7. Okay, then multiply. We get 21i. Add those, and we get multiply gives me 36i, and that gives me 0. So this factors into x squared plus 7x plus 12. Do I need to do the quadratic formula here? No, I could factor this. Factors into what multiplies to 12 and adds to 7? +4, +3. The directions were to give me the remaining zeros. It's an x cubed, so I should have 3 zeros. I gave you the first one. You're telling me the other 2. So what would make x plus 4 equal 0? -4. What makes x plus 3 equal 0? -3. So those are my remaining zeros. The final thing that I have on here, and that's what we're going to pick up with and keep working on Wednesday when I get back. All of these problems we were able to do because I gave you a starting point, didn't I? I gave you the first 0. So what if I don't? What if I don't tell you it divides it evenly? You have to find it on your own then. So that's where this rational zeros theorem comes in. Okay, it looks really complicated, but this is just saying if you have a polynomial, and that's the same definition of polynomial we've seen before, all the possible zeros, not every one that works, but everything that could work, will be as a form p over q, where p is a factor of the constant and q is a factor of the leading coefficient. So what we will be doing on these problems is making a list of things that might be a zero, things that might divide it evenly. This will give us not every possible zero, but all the rational ones, the nice ones that could be written as a fraction. And then from that list, we will find something that works, and that will be our starting point. So easiest way to do this is just start by example. We're just going to jump right in. Here is a polynomial. And we're going to do everything here. I want to find all the possible zeros, then find all the ones that work, and then write it in factored form. So you want to make sure you pay very close attention here. We will definitely be doing a lot more of these, but I may try to give you one to do on your homework for tomorrow. So you want to make sure that you know how to do that. So we start. The first thing I'm going to ask you to do, tell me your P and Q values. The P values come from the constant. So they are all the factors of that, everything that divides it equally. So in order to get -6, you could take +1 times -6, or -1 times +6, or 2 and -3, or -2 and +1, right? So all those things that divide it evenly would be 1, -1, 6, -6, 2, -2, 3, and -3. We'll always have all the positives and negatives, so what you have to do is plus and minus. So the things that divide 6, positive and -1, positive -2, positive -3, positive -6. Those are the only numbers that divide 6 evenly. You have to have the plus and minus on those. I will take off if you don't. For the Q values, Q comes from the leading coefficient. What are things that divide 2 evenly? 1 and 2. You could take +1 times +2, or -1 times -2. So that, again, you will always have the plus and minus. From there, we do our possible zeros. That theorem told us that our possible zeros are P over Q. So if you did 1 over 1, okay, you could do +1 over +1, or -1 over +1. So can we agree we would still have the plus and minus on everything? So 1 divided by 1 is 1. So we have plus and minus 1. Then we would have 1 over 2, plus or minus 1/2. P over Q. So my next P is 2, so I can do 2 over 1. 2 over 2 is 1. I already have it, so I don't need to list it again. 3 over 1. 3 over 2. 6 over 1. And 6 over 2 is 3, but that's already on my list, so I don't need it. These are not the zeros. How many zeros should I have for this? 3 total. These are the things that might work. So we have two options for figuring out what does work from here. We could start plugging these numbers in. We know if it works, what should I get out when I plug it in? 0. So plug them in until you find one that makes it 0. If you want to save yourself a little time, you could graph this function first and see if you can tell from the graph. Zeros are just another word for x-intercept. So see if you can tell from the graph where it touches the x-axis. And then plug that number in to see if it equals 0. So I'm going to start there. I'm going to graph it first. Can you tell anywhere where it looks like it might touch the graph here? -6. How could I check to see if it worked? How can you be sure? 6 into there, right? Okay, I'm going to plug that in real quick. Just to make sure that's what it looks like. I want to confirm before I go anywhere further, so I'm going to plug it in. And I do get 0 out. Was that the only place it touched? No. I recommend, if at all possible, try to avoid the fractions when you're starting. But it does look like it also touches at 1, so you could try that. However, we found one, she said -6 worked. So all of this was to find that first 0. And then once you have that first 0, it's just like the previous problem. So what did we do first on the previous problems? We did synthetic division. So I'm going to do synthetic division with the -6. Now again, there are 3 possible zeros on this. So you might start at a different point. You might be dividing by something different, and that's okay. That's why the work is so important along the way. So if I do this division, this factors into 2x squared minus x minus 1. Now what do we need to do? Box method. So those multiply to -2 and add to negative. So that would be -2x and +1. Factor. So I get 2x plus 1, x minus 1. What else do I need in this? -6 works, so this has to be x plus 6. That is the factored form. So we just successfully factored a cubic without any starting point. I'm not done. I asked you for several things here. I said list the possible zeros, which is right here. Identify the zeros and write the factored form. I haven't listed my zeros yet. The zeros, what makes 2x plus 1 equal 0? -1/2. What makes x minus 1 equal 0? What makes x plus 6 equal 0? Were all of those on my list of possible zeros to begin with? Yes. Okay. So we've done a lot today. Are there any questions right now? I want to encourage you tomorrow, bring these notes to class with you so that when you're working you have something to look back at. You might also want to look at book examples. If you forget how to do something, check back in the book. Yeah, give me 1 second. So, let's kind of talk about where we're going to go from here. If you look at the very last slide on this handout, I'm going to make one modification. I put the day 1 assignment. I do not want you to do problem 37 yet. I'm actually just going to drop that down to the next day because we only got through one example like the following. So, for tomorrow, on that first handout, you have the assignment on the back. And then on this one, you have the assignment. So you guys have your homework already. Tomorrow is a work day. You may help one another, but you have to be working. I'm going to put in my note that if you're not talking about the math, then you're not allowed to speak anymore. So, make sure you're focused on what you need to be doing tomorrow. If you get stuck on something, help one another. I'm giving you a lot of odd problems. On the previous section, they were all odd, so you can check yourself in the back, talk to each other. If you need help, shoot me an email, come see me before or after school, advisory. I want to make sure we get our questions answered. Both of these assignments then should